Okay, this is the P3 paper from January 2021. It's question number 4, and if we take a look at it, it's a functions and graphs questions, and in particular, it's a modulus function question. Okay, let's make a start. Let's have a look at it. It says we've got this sketch here, which is y equals fx, where fx is that function there, modulus 3x plus a, all of that modulus, plus a. And it says the graph has a vertex at the point P. Can we find the coordinates of point P? Well, yeah, I think the easiest way to attack these types of questions is just to see if we can sketch what that looks like. So I'll tell you what I'm going to do before I do it. I'm going to draw a graph of y equals 3x plus a. Then I'm going to see what happens when I modulus that graph. Then I'm going to see what happens when I take that graph and add a to it. Once I've got that sketch, I'm only particularly interested in the vertex, but we'll see what other points come up as a result of doing that. Okay, let's go ahead and make a start to that. So what I've done in advance is just to draw out a set of axes here. So as I said, the first thing I'm going to try and do is draw the graph of y equals 3x plus a. So I think y equals 3x plus a is a straight line. It has a gradient of 3, which just means it's positive. Okay, so at least it's in that direction. It's hitting the axis, the y-axis, at the point A. So this is the point 0A here. But actually, I'm probably more interested in is that value there, and that value there is going to be when y equals 0. So let's just go back up there in a bit of space and sort that out. If we've got that part A, fx was equal to 3x plus a, that's the question. But now for y equals 3x plus a, I want to know when y is equal to 0. So 0 will equal to 3x plus a, so 3x is equal to minus a, so x is equal to minus a over 3. Right, okay. So this value here is minus a over 3. That's the graph of y equals 3x plus a. Now, if I was doing this and wanted to really take my time over it, I could now just draw out another set of axes to do the modulus and do the plus one. It's only worth 2 marks. So I think that I'm showing you here the final version of what I do is actually what I'd end up doing. This might all be a little bit of rough work to the side of the actual exam paper. Right, so that's what 3x plus a looks like. I now want to do modulus of it. And if I'm going to do the modulus of it, hopefully you're aware that what that means is that those negative values now all need to be flicked up to the other side to go up there. So I can do that really easily. So on here, what I'm now going to have is that my graph looks like that and not that bit in there. Well, I'll just delete that using the iPad. Give me 1 second. So that's okay for me to just delete that. And now what I can do is maybe draw that line in again, but to just focus on this point here, which at the moment is minus a over 3 naught, is what's going to eventually become the vertex here. And now all I need to do is my final transformation to add a on. And again, hopefully we're all aware that adding a on is just going to mean that the whole graph moves up by a units. So if the whole graph moves up by a units, then if I do that, that's going to move up. And instead of now being the point minus a over 3 naught, it's now going to become the point minus a over 3 a. The point that was 0a, again, will also now become the point 0 2a, but they were only interested in the vertex. They're only interested in the this part here, P. So we can now say P is the point minus A over 3A. Just make sure that's nice and clear. Handwriting's not brilliant there for that A here. Make sure that that's the letter A there rather than anything else. Okay, so that's the first part done. What does the second part say? The second part says, right, for part B, can we sketch gx is equal to modulus x plus 5a? Well, I'm basically going to do that exactly the same way as I did the last one. Maybe go through it a bit quicker here. So for part B, oops, let's just copy that out. Okay, so I'm going to have an axis here, and then if the graph that I'm trying to draw is gx equals x modulus x plus 5a, what I'm going to do is I'm going to start off, I'll do it relatively quickly here, I'm going to start off with y equals x, so y equals x plus 5a would move up there. Y equals x plus 5a now, and because it's y equals x, we can automatically say that's minus 5a there. If you want to do the business again about saying y equals 0 and rearranging it, we're going to get that, but I want to just save a little bit of time there. So modulus of x plus 5a then means now, again, that at that value there, we don't have any negatives. And so that's my graph for for gx equals x plus 5a. That's the graph of that one. Let me just put the modulus signs in around. Did that a little bit quicker only because I took quite a bit of time over part A. It's basically the same sort of knowledge base. Let's go and have a look at part C then. So for part B, on sketch, show the coordinates in terms of A, each point where the graph cuts or meets the coordinate axis. So yeah, we've done that. Then for part C, it says the two of them intersects. Find where they intersect. Find the coordinates of the 2 points where these two graphs meet each other. Okay, so for part C, this is going to be some modulus equation work. I've got x plus 5a, one of the graphs, equaling 3x plus a plus a. Right, so if I want to find the 2 points where these two graphs meet, let's just consider everything positive first of all. So I'm going to look at this bit here, and I'm going to consider what happens if that's positive, and then what happens if that's negative. So consider 3x plus a positive. You don't really need to, this is more explaining it to you. I wouldn't necessarily write this down on my own work here. You'd just say, well, x plus 5a equals 3x plus a plus a. If this bit is positive anyway, then the modulus sign has made no difference to it. So we'll just need to solve that, rearrange it and solve that. So what we're going to do is we're going to get x plus 5a equals 3x plus 2a there. So take the x over to that side and the 2a over to that side, and I'll end up with 2x equals 3a. Okay, so x equals 3a over 2. And if x equals 3a over 2, what's the y value going to be? Either put it in there or put it in there. It makes most sense to put it into the more simple one, which is the x plus 5a, modulus x plus 5a. So y is going to be modulus x plus 5a. So it's modulus x plus, it's modulus 3a over 2 plus 5a, which just works out to be 13a over 2. Okay, so that's one of my answers. X equals a over 2. Got the handwriting sorted out on that. Y equals 13a over 2. And what about if we consider 3x plus a, if instead that was a negative value, then we'd get x plus 5a equals the minus of that, so minus 3x plus a, and we're just going to do the same thing again, solve this time. So I get x plus 5a minus 3x minus a plus a. Well, those two cancel each other out. Rearranging all of that is going to give me 4x equals minus 5a. So x equals minus 5a over 4 this time. And again, putting that back into the y to work out what the y value is. Again, seems easiest to stick with the simpler of the two. So I'm going to get y equals minus 5a over 4 plus 5a, which is going to give me y works out to be equal to 15a over 4. So we get two different points, either the point 3a over 2, 13a over 2, or the points 5a over 4, 15a over 4. But that's everything we wanted. It said find, in terms of A, the coordinates of the 2 points. Okay, so that's that one finished. Hopefully that all makes sense.